Okay, so I assume this is just things aren't declared in the right order anymore because I move stuff around. Yep. And I want to change the system actually as well. That's something I didn't discuss. Because I want to move this logic that was currently being run in the renderer into the manager logic, even though there's no manager, I want things to work a little differently. Currently, there's two lists at swaps between them, so it's sort of double buffering. And what I actually want to switch it to is there being three lists, sort of like triple buffering. The reason for that is very straightforward. There are two things that want to process the lists. There's a renderer that wants to create them, and there's the background system that wants to consume it. And double buffering is kind of the obvious thing. There, the renderer can fill one out while the thing is processing them. But it actually is what led to this dumb try-lock mutex thing, because it can't swap between them if either system is currently processing. So if we have three lists, then there's always a third one. There's one that the renderer is processing, one that the background system is processing, and a spare. And that means the renderer can always swap to the spare safely. So yeah, I don't actually want the tabs versus spaces discussion to get into it, and it's fine if Ebner wants to prevent it from happening in the thing, and I just took advantage of the fact that I'm the person on the stream to offer my opinion, but rather than my opinion, I instead offered, here's like some ground rules on the discussion with the JWiz link, and I think that's, sorry for pronouncing JWiz, like that's just how I pronounce it. I don't think anyone else does, but not because I wanted to stake out a position in the tabs versus spaces, but just because I think we should avoid arguing about the things that aren't what anyone actually cares about, or what people should care about, which is what that link advocates, is that there are things we should not, that are not actually relevant to the argument that people keep bringing up. And like I said, I think maybe people are less bad about that these days, but I just wanted to take advantage of my bully pulpit, there's the phrase I was looking for earlier, to take advantage of my bully pulpit, there's the phrase I was looking for earlier, to offer that little bit of info. Okay, so all this logic, little bit of info. Okay, so all this logic needs to happen. All this logic needs to happen, but none of the locking info. Okay, so all this logic needs to happen, but none of the locking info. Starvation count, lock. All this logic needs to happen, but none of the locking info. Starvation count, locked. This is not going to be in swap requested meshes anymore. We don't need any of that. All right, so let's go ahead and move this down to here. Uh-oh, did I delete something and never paste it? So what I do when I want to move stuff around in my code, move this down to here. Uh-oh, did I delete something and never paste it? So what I do when I want to move stuff around in my code is I delete it into my copy buffer and then paste it somewhere else. But sometimes I get distracted and forget to paste it, and then it's gone, which is kind of bad. Because then I do another copy like I just did. So the question is whether, what was the code I was just thinking about that I might have put in my copy buffer? I've already forgotten. By explaining it, I immediately forgot what it was that I was thinking about. Oh, the declarations of those things. Yeah, I think it did. I don't see them anymore. Oh, no, I did. Okay, this. I did paste it. Okay, good. For a while, I ran a little app that monitors your clipboard and just copies whatever was in it into its own thing and keeps the last 100 or last 1,000 or something like that. And I started running that basically because I had that happen to me a couple times where I lost stuff in the copy buffer. But it never happened. I ran that thing for like 2 or 3 years and literally never used it. And so then next time I set up a machine, I didn't bother reinstalling it. All right, I'm catching up on chat again. As always with chat, I do try to skim every. As always with chat, catching up on chat. All right, I'm catching up on chat again. As always with chat, I do try to skim everything in chat. But I'll start skimming a lot faster when it's doesn't seem relevant. So always do an @nothings to if it's something you specifically want me to notice, because I will see those. Even if you're not addressing me, if it's something relevant to me, rather than whatever the chat has meandered into, go ahead and like tag me at the end or something. Does that work? I assume that works. Okay, good. Nothing being said is relevant. All right, so I need 3 lists now. And this is the API. That's old enough that it might still be accurate, but I'm just going to delete it. Okay, so this is the render. This was the render request it, and this is when we've filled it out. And rather than change the API, this way I'm just only going to touch this file. So rather than change the API, I'll do this stuff. So we're going to rename these things. Requested mesh. Current processing. Current next renderer. Next, what is this? What would this list be called? Next requested next. So this will return empty. This will give it a little longer. The actual, I was doing this with meshes, not mesh list. So let's use that. Okay. So we return empty meshes, and then when we swap, we know empty meshes is done. So we SDL lock mutex. What were the mutexes? Oh, I put them into the top of the file. Swap renderer request mutex. Swap renderer request mutex. Did I create these mutexes? Let's make sure I did that. Yep, I did. Okay. I'll remind you of the trick I just used to switch between places in the file. This is a trick that works in all editors, basically. Here is where I was. Places in the file. This is a switch between places in the used to the trick. I'll remind you of the trick I just used. I'll remind you of the trick I just used to switch between places in the file. This is a trick that works in all editors, basically. Here is where I was that I want to swap back to. Well, let's show you when it's arbitrary, when I haven't just edited it, just to be a little clearer. Say I want to swap to here. And I can just do this in any editor without having to learn a whole like bookmarking scheme or something. I make a change and delete it, or delete something and redo it or whatever. And I save because I reflexively always save after every change. And then I do whatever thing I want to do because I want to browse to the end of the file here. So I browse down to the end of the file and I look at this. And when I want to go back where I was, I hit undo, which jumps the cursor back because it wants to show me what it just undid, and then redo. That will always put you back to the last thing you edited. And if you haven't, if what you most recently edited is not the thing you want to be looking at, then you have to do a little dummy edit. If the most recent thing you've edited is the thing you most recently did, you can just do that. So that's a dumb little trick that basically works everywhere. And I only figured that out 10 years ago, maybe? 36 years of programming. So is that number right? Yeah, something like that. So I went a long time without learning that trick. And I've explained it before, but different people watch these streams, so worth mentioning again. So we just need to swap them. Listed mesh. Most recent renderer meshes. Most equals empty meshes. Okay. And then we want to swap the most recent render. So let's set a flag here. It probably doesn't need to be volatile, but right, you need a memory bearer because this is protected by that mutex, so it's a little awkward. And volatile is the. I wish all compilers had this semantic for volatile. I wish it wasn't with just MSVC. Because it's such a light, since it's controlled by the mutex anyway, it's such a light semantic that you need for it. And volatile conceptually is what you always save after every change. And then I do whatever thing I want to do because I want to browse to the end of the file here. So I browse the cursor. Always put you say edited it works at 36 years of programming. So is that number right? Yeah, something like that. So I went a long time without learning that trick. And I've explained it before, but different people watch these streams, so worth mentioning again. So we just need to swap them. Listed mesh. Most recent renderer meshes. Most equals empty meshes. Okay. And then we want to swap the most recent render. And so let's set a flag here. It probably doesn't need to be volatile, but right, you need a memory bearer because this is protected by that mutex, so it's a little awkward. And volatile is the. I wish all compilers had this semantic for volatile. I wish it wasn't with just MSVC. Because it's such a light, since it's controlled by the mutex anyway, it's such a light semantic that you need for it. And volatile conceptually expresses the right thing, the conceptual description of volatile, that it's something an asynchronous hardware could be doing for you. Is renderer valid? And it always will be, right? No, it won't. Right. Okay, which is why I want it. So right here is renderer meshes valid. That's true. Or that was an accidental capitalization. Renderer meshes valid. So whenever we swap in from the renderer, it's definitely valid. Swap. Current processing. If is renderer meshes valid. That's not inside the lock, but that's okay. We could do it inside the lock too, but hyper optimized for no good reason. If it is valid, then we're going to swap it, and that one becomes invalid. So temp is most render. Most render is current processing. Meshes. Oops, I misspelled it. How long have I been going? Okay. Unfortunately, the new Visual Studios have a complex algorithm. i.e. who knows, to determine whether to actually jump back to the line undone. Well, that's terrible. This trick obviously works because normally editors jump back to the edit. I could imagine something that when you did the redo step, decided to jump forward back to where the cursor was, but that's dumb. Maybe there's some good reason for it. But this trick is so convenient. If you are ever designing an editor, this trick is so convenient. Make sure your undo and redo have this result with the cursor. Your undo and cursor movements, you don't generally want your undo and redo to record. And that would be the reason why they might be trying to do it. There was a time when undo wasn't universal. Certainly back when I was starting to program, I had no undo at the time. So that's certainly part of why I didn't learn that trick. But it definitely was around 10 years ago. I'm talking about a particular thing in chat here, which isn't worth talking about in the stream. Okay, so current processing, most render, that seems reasonable. It's invalid now. We unlock the mutex. It seems all fine. Let's go ahead and just do that. Okay, so current processing, most render, that seems reasonable. It's invalid now. We unlock the mutex. It seems all fine. Let's go ahead and just do that. Even though it's totally fine without it, let's just do that. Maybe the volatile isn't needed. See, the problem is without volatile or memory barrier or something, if this function separately compiled, knows it has to load that from memory because it's separately compiled. It has no way of knowing the value of that. But you could imagine hypothetically cases like this where this function gets inlined into something, and then it can go and look and say, oh, I see that the only thing you ever assigned this to in this loop is false, and so I can prove that it never changes value. And that's why I go with the volatile, because it's to describe that idea that it is getting changed asynchronously elsewhere, even though that's not. It's actually, for whatever reason, the people in the spec or whatever decided that doesn't apply in the thread case, that they're not going to make the compiler generate the code necessary for the thread case for it. And maybe there's some good reason for that, I don't know. But they didn't then also add a volatile too that does the right thing. Obviously, it's the C++ now has the atomic stuff. They've kind of addressed that, but C hasn't, I think. But it doesn't matter because I'm stuck with pre-C99 anyway. What are good unions in the good unions? What are good unions in the in your opinion? Is that like typed unions or something, or tagged unions rather? We're super chatty. Yeah, tagged units. Okay. I may never be done. Who knows? Maybe I'm just going to keep going for. Who knows? Maybe I may never be done. I may never be done. Yeah, tagged units. Okay. Yeah, tagged units. Okay. I may never be done. Who knows? Maybe I'm just going to keep going for 200 days straight without sleeping. So we swap these. Now we need to call this swap current processing. And now we need to call this swap these. Okay, so we swap these. Now we need to call this swap current processing. And we can just do that. Okay, so we swap these. Now we need to call this swap current processing. And we can just do that here. Let's return. Why do I keep doing that? I do that because of the STB stuff. There's no bool type in C, and I don't want to define an STB bool and use that everywhere. It's just too wordy. Or in fact, it has to be that if I'm trying to avoid polluting the public namespace. And it's just super wordy, and so I just end up using int in STB stuff all the time. And then it creeps back in. It's a bad habit. Okay, so then swap them. And if it succeeds, then we should do this processing, but otherwise we shouldn't. And we don't do this swap anymore. Okay, so we swap these. Now we need to call this swap current processing. And we can just do that here. Let's return. Why do I keep doing that? I do that because of the STB stuff. There's no bool type in C, and I don't want to define an STB bool and use that everywhere. It's just too wordy. Or in fact, it has to be that if I'm trying to avoid polluting the public namespace. And it's just super wordy, and so I just end up using int in STB stuff all the time. And then it creeps back in. It's a bad habit. Okay, so then swap them. And if it succeeds, then we should do this processing, but otherwise we shouldn't. And we don't do this swap anymore. Okay, so now let's actually look over what it's doing. I believe it's copying it into another list. Oh, it's copying it into its own list. I see. Yeah, tag units. Okay. I may never be done. Who knows? Maybe I'm just going to keep going for 200 days straight without sleeping. So we swap these. Now we need to call this swap current processing, and we can just do that here. Let's return. Why do I keep doing that? I do that because of the STB stuff. Oh, it's copying it into its own list. I see. Okay. So we take the current list, which is the wrong list. It should be current processing meshes. And if we hit invalid, that's the end of the list. Just because I don't have counts for them, just to keep my life simple. Again, that's this opinionated chatting that I don't think makes sense on the stream. Maybe it does, but it would be time delayed, so I don't want to. All right, so if we swap, we go through, we check if it's already processing. If it's already processing, that means it's nearly done, and we're just going to delete it from the list so we don't think about it anymore. We don't bother doing that on successive times currently because I put this inside the if. So I should check whether there's anything else going on in here. Maybe it shouldn't be inside the if. Okay, and then when we finish going through, if it's not processing, we mark that it's new in the list. This is the first time we've seen it. So that does definitely have to live inside the swap. And then we copy it because we're compacting this list as we go. And then when we get to the end, we add the invalid tag on the end in case we compacted it. Then we go back through again. Right. This is this thing where you need the old lists before the renderer. So we need 4 lists. We have to do a little bit of a delta of the 2 lists, basically. And So the thing is, it's the 2 lists that are here. So maybe I want to make this, maybe I don't want to make this a function. We just want to do all of this logic and all of this logic, but it all needs to be inside this mutex. I guess the STL claims those mutexes are reentrant. I just wonder if that's a performance cost. Well, I can't really avoid it because they don't have a non-reentrant mutex. So I could just wrap the whole thing in a mutex, I guess. Okay, great. Let's move on to type theory. Wonderful. On to type theory. Okay, great. Let's move on to type theory. Wonderful. STL mutexes are reentrant. All right, well, let's just rely on that. That allows us to keep that modular. So we just say STL lock mutex swap render request mutex. And the downside of this is that means all of this processing is going to block the render thread. So maybe we would want to switch back to that try lock. Right, because we have to process the whole list. Okay, great. Let's move on to type theory. Wonderful. STL mutexes are reentrant. All right, well, let's just rely on that. That allows us to keep that reentrant. All right, well, let's just rely on STL mutexes are reentrant. STL mutexes are reentrant. All right, well, let's just rely on that. That allows us to keep that modular. So we just say STL lock mutex swap render request mutex. And the downside of this is that means all of this processing is going to block the render thread. So maybe we would want to switch back to that try lock. Right, because we have to process the whole list. Right, the swap is incredibly cheap now. The render barely gets blocked at all. Right, but now we have to iterate the whole list, iterate the whole list, iterate the whole list. This last one we could do outside the lock, but only if we expand up the locks, to be clear. Do this. Okay, so current processing meshes, boom. This is current processing meshes, not requested meshes, alternate. Then we want to go through these were alternate and this was alternate? I think this was broken. No, but that would have just... I'm not sure this is right. I think it was traversing the wrong list here, because it should have been traversing the other lists. Unless I'm missing something. I believe this wants to traverse the list it just swapped out, which is most recent renderer meshes. Which is not semantically, that name is not semantically correct. That might have been a bug. Not sure what the consequences would be. Maybe I'm missing something. So the reason that this is all now inside the mutex again is this, so that I can access most recent renderer meshes in this loop right here. That was the reason I needed to keep it around. Keep it locked. It's all now. So the reason that this is all now inside the mutex again is this, so that I can access most recent renderer meshes in this loop right here. That was the reason I needed to keep it around. Keep it locked. But this is the list that we used to set this flag. So this one wants to be this. And since this doesn't access it, we can move that up to there. Premature optimization. It's just such a small change. Why not? Of course, max belt meshes we should be keeping relatively small, right? Yeah, with 16 plus 16. So this shouldn't actually do too much looping. So maybe that is premature optimization. It's going to loop over 32 things. It's going to do a get chunk, at most 32 things. It's going to do a get chunk status on each, which is just a cache. It should be in the cache from these previous loops. Yeah. All right. We'll accept that that is. Why can't I select a line here? Oh, I accidentally hit the muck. We'll accept that that is premature optimization and put it back. And it actually, we do it outside the if. Okay, right. Not sure what n is. It's not initialized there though. Where do we use n here? So it's part of this loop. Again, I'll remind you, if I should be saying anything, do tag me in the chat so that I know to read. Okay, so so now, I guess that's what Renderer requested really was. So we could use that name again. I assume we don't use that ever again in here. Looks like it. Maybe. I don't know what else I need to do. I'm sure there's stuff to do, but I don't know what it would be. Your bowl? Declaration. Yeah, that's fine. Deleted all this. Volatile. Int stop worker flag. stop manager for now. Stop worker flag equals true. Yeah, right. And I said I'll come back to that. Don't know if I want that anymore. Okay, it compiles. I do not. Okay, it compiles. I do not expect it to run. I'm not even going to try to run it yet.
It's been snowing for years, and we just don't know.
Well, you can't just tag me. Well, you can't just tag me. To tag me in the message what your question was.
Just sit by your fire.
Oh yeah, I'll let the chat answer that question. I'm too overqualified to answer. I'd put that in the fact, but that I never have a useful answer for beginner-ish questions, but I don't think anybody would check the fact. We get so many questions that are already in the fact. And the chat is happy to answer it, so it's probably better to just let the chat answer it. So, what are the things I know I still haven't done? There was something. There was something I haven't done. What are the things I know I still haven't done? What are the... So, what are the things I know I still haven't done? Well, you can't just tag me. You have to tag me in the message what your question was. So, what are the things I know I still haven't done? There was something. There was some stuff that I hadn't done yet. I don't remember. What was the stuff I hadn't done yet? Should have written down on the to-do list. Check the to-dos, but I don't think I had to-do it. Yeah, these are all old to-dos. Yep, nope, there's no to-do for it. But there was something that I didn't do. There was something I skipped. Other than the shutting down. The shutting down I'm cool with skipping. Oh, right, it's when they run out of work. The out-of-work problem. Okay, so when they run out of work... It's right here. So what they want to do is all of them want to come in here and sleep. And then the renderer every frame wants to wake one up if there is one. And if there isn't one, it doesn't need to do anything. So I think we can use the waitable waker for that. I think that does the right thing. Well, you can't just tag me. You have to tag me in the message what your question was. Oh yeah, I'll let the chat answer that question. I'm too overqualified to answer. So, what are the things I know I still haven't done? There was something. There was some stuff that I hadn't done yet. I don't remember. What was the stuff I hadn't done yet? Should have written down on the to-do list. Check the to-dos, but I don't think I had to do it. Yeah, these are all old to-dos. Yep, nope, there's no to-do for it. But there was something that I didn't do. There was something I skipped. Other than the shutting down. The shutting down I'm cool with skipping. Oh, right, it's when they run out of work. The out-of-work problem. Oh, right, it's when they run out of work. The shutting down. Other than the shutting down. Other than the shutting down. Other than the shutting down. The shutting down I'm cool with skipping. Oh, right, it's when they run out of work. The out-of-work problem. Okay, so when they run out of work... Okay, so when they run out of work... Okay, so when they run out of work... It's right here. So what they want to do is all of them want to come in here and sleep. And then the renderer every frame wants to wake one up if there is one. And if there isn't one, it doesn't need to do anything. So I think we can use the waitable waker for that. I think that does the right thing. The only problem is that the renderer could keep waking up multiple ones, even though there's nothing for any of them to do. But I think the wakeable waiter was meant to do this. I was only using it to communicate between two threads, or there was only ever one thread waiting on it. But I assume this is designed so that multiple threads can wait on it, because it's got the mutex around it. Well, that could just be for communicating to the other things. Guess I really need to know what conditional wait does. And the STL docs were not helpful about that. I remember I had to figure this out back when I did it the first time. Threads, condition variables, not conditional. Alright, so what are conditional variables? And why did I have to add an extra mutex to the waitable waiter? Why was condition variable not enough? Only one guy can wait or wait. Yeah, okay, this is not multi-thread friendly because only one guy can wait or wait. This was designed to allow multiple wake-ups to come in. And yes, okay, I know what the purpose of this. This allows multiple waiters to, multiple things to wake the thread and not get missed. There's that not get missed that I was talking about. The idea being that two things, okay, so when they run out of work, it's right here. So what they want to do is all of them want to come in here and sleep. And then the renderer every frame wants to wake one up if there is one. And if there isn't one, it doesn't need to do anything. So I think we can use the waitable waker for that. I think that does the right thing. If the waiter is currently waiting, then it's okay to get multiple wake events compressed into one. But the moment the waiter starts running outside of this code, any event that's signaled at that point definitely needs to get signaled. So that's what the semantics of this are. But that is not the semantics I need now. Now the semantics I need are multiple things waiting, and one of them gets woken up, and it's okay to miss events actually now. I mean, that is what a condition variable is. Why does it take a lock as a parameter? It will automatically release the mutex while it waits. Okay, so this is useful for multiples. I hadn't understood that. Okay, so I think this waitable waiter is what I want. We'll try it. What's it called? Monitor. Which is, of course, a monitor is a kind of synchronization primitive as well. Is that why this is called a monitor? Is waitable waiter a monitor? Marcus, this is mutex and condition variables. Yes, so I think on stream somebody taught me how to make those or something. Yes, a semaphore does not express the. Yes, a semaphore does not express the semantics that we want here. That's what a monitor is, the semantics we want, and a monitor is a mutex aggregated visual variable. I do not think you can use a single semaphore to simulate this effect. Both mutual exclusion and the ability to wait for soon to be true. Right, in a like maybe a saturated semaphore or something like that might be able to do this. Which maybe semaphores are, but the SDL semantics does not guarantee they are cross-platform. Alright, so what we want to do is bool did wait was false. So if we ever wait, what we want to do is bool did alright, so what we want to do is bool did wait was false. If we ever wait, then when we get the next task successfully, we hit here. If did wait, then we want to waiter wake. Because if we got work, let's write this out as a comment. If we got some work, but we had been idle, then wake up the next thread. Let's see if it also has work to do. If we didn't get anything, then we won't wake anything up. We'll just iterate back around. Now the only problem is how to get the if stop worker flag to work, and that I don't have to solve yet. All right. Just somebody in chat. I'm not sure. All right. Just somebody in chat. I'm not sure. Asking questions in good faith because hey, why not waste everyone's time? And then when the renderer swaps, which is up here. We also need to waitable waiter wake manager monitor. Is that what it was called? Address. Why is that address off? Okay, it is. Whatever. Oh, right, because SDL is not an SDL primitive. It's my own primitive. So it's just a direct type instead of a pointer. Maybe? Probably not. Maybe? Probably not. Yeah, they need to. All right, processing. Oh, let me bring this back to the top. OBBG. All right. Yeah, they need to. All right, processing. Oh, let me bring this back to the top. OBBG. I can't show you a screenshot because I'm in the middle of a. OBBG. I can't show you a screenshot because I'm in the middle. Let me bring this back to the top. Right. Processing. Oh, processing. Oh, let me bring this back to the top. OBBG. I can't show you a screenshot because I'm in the middle of a. I can't show you running because I'm in the middle of a big change. Oh, I still defined these. That's bad. I gave them all new names to make sure that I would find all the places and have to fix them because the compile would break. But if I leave the old definitions around, then they don't break. Oh, but I did find them all. Oh, I still defined these. That's bad. I gave them all new names to make sure that I would find all the places and have to fix them because the compile would break. But if I leave the old definitions around, then they don't break. Oh, but I did find them all anyway. Dun, dun, dun. Whoa, it's actually doing a whole bunch, although we died in the mesh builder here. Put chunk in cache, but the entry was already in the cache. Okay, so I think we managed to generate oh, I still defined these. That's bad. I gave them all new names to make sure that I would find all the places and have to fix them because the compile would break. But if I leave the old definitions around, then they don't break. Oh, but I did find them all anyway. Dun, dun, dun. Whoa, it's actually doing a whole bunch, although we died in the mesh builder here. Put chunk in cache, but the entry was already in the cache. Okay, so I think we managed to generate the same chunk. I think two things tried to generate the same chunk. Now, the way this all works is they create tasks, and when they create the task, it's supposed to flag that it's being generated. But maybe there was some code that was dependent on the queue. Can start procgen. Yeah, it probably used to have code there that actually flagged that it started the procgen, and I accidentally lost it. What was I about to do? I've already forgotten. Why did I open up a command window? The chunk already existed. I'm trying to recreate all the same logic. So it was never calling output procgen. Right, so I was going to do a git. It was never calling output procgen. Right, so I was going to do a git diff. And see if I can see the code that I deleted. Yeah, it's this. It's start procgen, probably. So somewhere there's a called the start procgen that I deleted. the end progen? Where's the begin? The start progen? Did I do a start and end pair again? Yeah, I did. Oh, I know I'm past it. Somewhere in here there should have been a start progen. This red is so unreadable. Alright, there's no magenta progen in here. Okay, right, because that's the job. That's the thing actually doing the work. It would be in the worker manager. Start progen, right there. Somehow that line got lost. I don't know how it got lost. Watch, I'll get up here and it's not missing. I deleted these lines, but I shouldn't delete that line. Okay, there we go. Okay, there we go. I deleted these lines, but I shouldn't delete that line. I deleted these lines, but I shouldn't delete that line. Okay, there we go. So, did I fix it? Is this all wonderful and working? I don't know. Let's go a little distance. Let's fly. Oh, if there are new watchers, we're up to 70 people, so I'll show a little of the factory stuff running. This is all super optimized, memory efficient, instanced. The contents of the conveyor belts are incredibly compact. They're 1 byte per object. They're moving continuous at frame rate using animation, a simple animation system, and the simulation ticks are relatively sparse. Although that just means that the CPU load spikes every so often. I can't point at the screen and I don't have a mouse cursor, but the frame render time includes the sim time, I think, and is probably spiking every 12 frames. And I didn't worry about lining up the thing it's carrying yet. So yeah, that's what this is. Yes, it's kind of a Minecrafty game with a much longer view distance. And this is a debug build, so you can see the stuff pop in, but in a release build you shouldn't see the stuff pop in. Unless it's possible that the current task system isn't working as well. It may be like I need to put in a real time estimate of how much time the worker threads are running, so we get an actual like CPU load kind of result from them. Casey has not asked me to talk. Casey has not Casey has not asked me to talk. I guess I shouldn't say. It's supposed to be a secret. So even a negative is information that's potentially you shouldn't have. So I suppose next time anyone asks me, I won't answer. Next year. I have no idea who he's trying to get. Why is number of tries increasing like it is? Why is number of tries increasing like it is? Is it increasing? It's, well, so depends where I'm looking. Why does it depend where I'm looking? I think because it hasn't filled in the terrain in that direction yet, because it is being slow to build. The background system is slower than it used to be. Oh, because I put max tasks. No, but we don't use max tasks anymore, do we? Max task doesn't even exist. Something is causing it to be slower. So there was more data in because I'd moved away from the origin. There was more data in one direction than the other. But you will also see, like, depending on where the forests are, you will see different numbers of triangles in different directions. Right now, it's slowly increasing. Also, just as it's building the stuff out to the distance, as it's slowly popping in. We can bring up the full stats of it. You can look at the VBuff storage line, showing. There's 50 megabytes of stuff in the cache currently, and that's slowly increasing as it builds out to the distance. Okay, so I should find out why it's slow, because I've made all these changes. Let's go ahead and commit it since it's working. Okay, so I should find out why it's slow, because I've made all these changes. Let's go ahead and commit it since it's working. Oops, that's wrong. Let's go ahead and commit it since it's working. Oops, that's wrong. Did that work the first time? So that's, but I don't remember if that worked the first time. I think I had to fix something, but that's what I meant by it being a new, simpler system. Of course, now maybe there's some performance issue. The trolling persists. Okay, so what stats? Okay, so what stats are there in this system that control how fast it can build stuff? There's the number of mesh workers. Let's check that we're still getting 3. Yep, we're still getting 3. There's the extra processing it has to do. There's how long the list is when it comes in. Wait for them all to finish. Then let's do, we don't have a finished gen list anymore, so we can just do this. And now this code is all gone. Okay, so what stats are there in this system that control how fast it can build stuff? There's the number of mesh workers. Let's check that we're still getting 3. Yep, we're still getting 3. There's the extra processing it has to do. There's how long the list is when it comes in. finish. Then let's do, we don't have a finished gen list anymore, so we can just do this. And now this, okay, this all gone. That's not going to affect anything except the shutdown time. So we still, now we're leaking more data than we used to. So we'll have to revisit that, figure out what's getting leaked now. That would make it slow if it was an actual leak. I guess I should check that. What's the? It's called monitor, but it had nothing to do with the monitor. It's this track allocated gen chunks in global table. Let's do that. Let's stop manager. Let's breakpoint there. Let's see if we have a ref count leak. Gen chunks is kind of stable. Num gen chunks 0. Okay, so we're not leaking gen chunks. So who knows what's leaking. Let's find the biggest thing that leaked. Something allocated at 1890 and something at 1891. Those might be one-time things. Our output meshes. Okay, so we might just have stuff in the built mesh queue that hasn't been processed yet. That's a lot of stuff in the built mesh queue that hasn't been processed yet. It seems like something might be going wrong there. But that's still just the same queue it always was. Get next. Maybe the swap render request mutex is causing a problem, like that we are doing too much work inside that. And that's slowing this down. No, that affects the CPU time, and we can see that's not spiking. Is there anything to pass in a parameter to the, yeah, point star I? They get their thread number. So let's output from the first one. We're not using moon graph. Did we define ODS? I think we did. I think I don't need the new line. I think that's going to double print the new lines. Doing lots of task 2s and occasional task 1s. They ought to be in a ratio of 4 to 1. And it looks like they're more like a ratio of 16 to 1. Implying that we're not sharing things properly. What would this be called? This is Ratio of about 10 to 1. That doesn't seem very good. Yeah, the conveyor belts. Conveyor belts. Each conveyor belt stores an array of pseudo items that are at quantized positions, and then animate between the. It draws them between the positions, even though they're fixed positions. And it's not actually each belt; it's actually each row of belts that are facing in the same direction continuously builds into one list. Just as an optimization, sort of, because that's so common. You're so likely to build. You're not going to zigzag. I mean, you might. If you zigzag, it will be inefficient. Yeah, the conveyor belts. Each conveyor belt stores an array of pseudo items that are at quantized positions, and then animate between the. It draws them between the positions, even though they're fixed positions. And it's not actually each belt; it's actually each row of belts that are facing in the same direction continuously builds into one list. It will be inefficient. Ooh, I think your stuff moves faster if you zigzag too. I think it takes 5 ticks on the outside and 2 ticks on the inside. So if you zigzag with the curves, it takes 7 ticks to go 2 diagonals. Whereas if you go in straight lines, it takes 8 ticks. Interesting. You also might be able to go faster if you zigzag straight at segments, actually, thinking about it. That might actually go even faster than that, which is kind of a bug. So yeah, another beginner question. I mean, maybe I need to. So yeah, another beginner question. I mean, maybe I need. So yeah, another beginner question. I mean, maybe I need to label this as an advanced stream. That's the whole point of this, is to show advanced stuff. People who want beginner stuff should go watch Handmade Hero. Okay, what was I doing? Oh, right. So the task ratio seems wrong, but I don't know what it used to be, so I don't actually know that it's wrong. Maybe we always had that issue, that it's not actually getting as much sharing as I'd like. That certainly will actually be true as you get out further from the center. Okay, what? Okay, what was I doing? Oh, right. So the task ratio seems wrong, but I don't know what it used to be, so I don't actually know that's wrong. Maybe we always had that issue, that it's not actually getting as much sharing as I'd like. That certainly will actually be true as you get out further from the center, because the things you're making are only overlapping partially. So everything should get used twice at least. So that would be 8 to 1. You really want it to at least see an 8 to 1 ratio. But okay, so the question is, why is it slow? Is it possible only one thread is running? Well, that's easy enough. We can output the third thread and check that it's getting stuff done. Oh, but it's possible that only one thread is running at a time. Because, like, maybe the manager monitor isn't working correctly. I don't know. What would cause this performance problem? the fact that I'm in the debug build. Although it still seems slower than the normal debug builds. Oh, and I'm still outputting that's going to be slow. Right. I think this will still be slow. I think there is a real issue. Yeah, that's building much slower than it used to. It looks like it's running one thread. That looks to me like one thread. I mean, I don't have a great intuition on this, but... So I think something's going wrong in all this. Okay, let's just have them not wait. They'll just keep trying. They'll just keep processing the list all the time when there's no work to do. Because there's always work to do at the beginning. Nope, they're faster. So yeah, if you look here, it's pretty hard to see, I think, in the stream, but there's yellow, not that yellow line there. There's the red. There's a little red thing, and the red shows each run of belts. So the corner is its own red square. And then, wow, that's so invisible on my screen. I doubt you can see it at all. So like from here, there's a line there. So that one goes all the way down to here. And then the whole system is divided up. Where's the pop of the... Where does it become transparent? Why is it not ever... Oh, here we go. So it's a little hazed, and when I get to a certain distance, it should unhaze. There we go. So this is... Why is there not a... Oh, I guess this stuff got positioned all within... Anyway, it's divided... This logistics system is divided into chunks. And there's a little hazed boundary between the chunks. Except I think it's broken. I think it's not actually rendered correctly. Yeah, that's the boundary between it. But it should be smaller than that, I think. I think it's not drawing... That's a huge area. I don't think the logistics chunks are that huge, are they? Weird. Yeah, that seems way too big. I thought the logistics chunks were smaller. What's the chunk here? Logi chunk size. Yeah, the Logi chunks are supposed to be 8 by 8. That thing we were seeing was not 8 by 8. Is that in the world render? 8 by 8. Logi chunks are supposed to be 8 by 8. Yeah, the Logi chunks are supposed to be 8 by 8. That thing we were seeing was not 8 by 8. Is that in the world renderer? I don't know who's drawing the... I guess it's in Logi somewhere. Drawbox, Logi chunk size X, Y, Z. I don't understand. It's not actually a circular list. It's not actually a circular list. It's not actually a circular list. It's actually does a mem move on the data every time it updates. But because the Logi chunks are small, like the longest the list can ever be is it's supposed to be 8 long, and there's 4 per thing, so it's supposed to be a max of 32 on each side. So it's 2 32-byte mem moves. So but on the sim, everything mem moves, but the mem moves is 1 byte per or slot, so it's not a big deal. How is that any list shared via networking? It's not. The plan is not to... how is that any list shared via networking? It's not. The plan is not to network this. The plan is to, make OBBG be able to be multiple things. And one thing it can be is a networked game. Like, I don't know, maybe I'll just make a shooter an FPS or something. And the other thing it can do is this effect. How is that any list shared via networking? It's not. The plan is not to network this. The plan is to, you know, make OBBG be able to be multiple things. And one thing it can be is a networked game. Like, I don't know, maybe I'll just make a shooter, an FPS or something. And the other thing it can do is this Factorio thing, and probably will not bother networking it. What might happen if I really want to make it all work as a single thing is sort of do a sloppy networking where, like, it's very coherent about the build of the stuff, and somebody is authoritative about the state of, like, the belts, and then it tries to incrementally give you info about the state, but locally you run the sim. And so the way you get most of the day is because you have the local sim going. And then when somebody, like, places a new machine down, it'll start to perturb the server's view of, like, where other ore is versus your view, because you don't know about the thing yet. And once you get it a little late, and now all of the data that you have passed there is wrong, and maybe the server just slowly, incrementally updates all of the ore. And so for a while, the sim that you're seeing is wrong when other people have put stuff down for the machine. But the state that's wrong is like, oh, there's one more of it, because normally you don't intermix like this. So typically what's going to happen is like, oh, there's a little more ore than there should be, or whatever. And that's actually not the level that you do reasoning about the machines generally. The reasoning that you do is like, which way is the ore going, and you know, is the right thing getting to the right spot? And that should always be self-consistent. Your sim locally will do something that is self-consistent for that observable stuff. And then once the stuff starts updating, it might not make sense if the update order is wrong. But I think it wouldn't be the end of the world. It might be a kind of a quirky thing. Like, this is kind of talking about the jankiness of Microsoft. One thing is that all these people new to games have gotten used to all these really weird, terrible things, like, you know, the pop in right in front of you, the really laggy networking when you get a spike, when you get a lag spike. There's some specific things, I can't remember what, with networking. And so people are maybe kind of used to that if they're exposed to Minecraft. And if somebody comes to this game from Minecraft, maybe some certain things like that we can get away with not feeling too bad. I haven't looked at how Factorio does its networking. So yeah, here you can see there's a bug that I haven't tracked down. I spent so long on the conveyor belts and fixing a little bug that I haven't tracked down. Here you can see there's a bug working. So yeah, here you can see there's a bug that I haven't tracked down. I spent so long on the conveyor belts and fixing little bugs like this. What you can see happening is that they animate forward because that's an animation system without them actually moving, but the color changes in kind of wrong place. And basically what's happening there is that the animation and the movement, internal movement, are actually getting out of sync in some way there. And it has something to do with the system has this whole crazy thing of keeping track of chains of belts, because to know that these are stopped, it has to know that these are stopped up here. And then what happens is every once in a while this thing picks one up and doesn't affect this part, but this part all needs to start advancing, and it has to propagate that information around. And that's why it has the belt runs, is because it allows it to do all that propagation, not one belt at a time, but in belt chains at a time. So it was just to optimize that step primarily. But there's some bug. And at the time I did all this, there were a ton of these bugs, and I fixed them all. There was like a bug as things went around a curve, the same kind of glitch would happen or something to the stuff back. And so I fixed all of that, but there was this one glitch that I hadn't noticed. And then there was another glitch, which is to do with, well, they're not doing it anymore. So do I have a way to clear it anymore? Oh, you do. It is doing it. You can see there's doubled up. For some reason, these things are extending back behind the beginning, and so there's two sets of things. What actually happens when it animates is it moves like this and then teleports back to here and moves like that. I don't know why that is. I haven't looked at that yet, just noticed it today. And I'm not going to worry about the conveyor belts right now. When I get back to doing factory work, when we finish all of the stuff we're doing right now, I'm still going to be working on the machines and ignoring the conveyor belts. The conveyor belt sim is all self-consistent. It's just the animation is sometimes glitching. All right, so it's still slow, and I don't know why. It's still slow, and I don't know why. Oh, wait, I was going to Debug. Why the box isn't the right size. So many changes. Why is this? What is that? Okay. So if we step in, SX, SY, SZ. Oh look, somebody. Oh, I'm in a release build. Dang it. $31 by $31. Okay, why is it 31 by 31? Logi chunk size X. Oh, I switched it to being gen chunk sized. I didn't remember doing that. Why did I do that? I left Z that, but I made that. I mean, it was always that, and I just forgot that it was that small. Or that large. Anyway, that's fine. Whatever. Okay. Anyway, that's fine. Okay. Just want to make sure I know what's going on. So now, why was I visualizing that? Oh, it was to show that it was divided up on each chunks, but it happens to all be in the same chunk. The original tests I were doing wasn't like that. But this thing I happen to build all in one chunk. Yeah, all of it. So you don't get to see the stuff in the chunk boundaries. So it has to do extra logic because it tries to process each chunk independently, but it needs to do extra logic when stuff crosses chunks. So it's a whole lot of complexity. This is advanced coding because I'm this is advanced coding because I'm trying to be really high performance and really efficient memory usage. That impacts lots and lots of things and keeps things from being simple. And then I'm solving hard problems like the background threading stuff. And then my coding style also is less clear because I try to keep things compact. And because I'm not putting in comments, because I tend to explain things on the stream instead of putting in comments, which is just a bug in my process when I'm streaming. This is advanced coding because I'm trying to be really high performance and really efficient memory usage. That impacts lots and lots of things and keeps things from being simple. And then I'm solving hard problems like the background threading stuff. And then my coding style also is less clear because I try to keep things compact. And because I'm not putting in comments, because I tend to explain things on the stream instead of putting in comments, which is just a bug in my process when I'm streaming. Okay, so we still need to figure out why this is slow. So we still need to figure out why this is slow. As far as I can tell, we're just doing the same thing we used to do. So does STL have a timer? Time. Does this have a high res timer? I assume it doesn't. Like get ticks the slow shitty thing that's the Microsoft get ticks probably. Yeah, I mean at that precision, you want the high precision, and I bet STL doesn't have it. Maybe you can't get it on all platforms. I can just let this be Windows for the profiling could be Windows only, so I could just directly use Query Performance Scanner. So somebody typoed their their so somebody typoed their the tag for me when they tagged me in the chat and left out the S and said nothing to, and that doesn't, so that way it doesn't highlight in mine, but since you're not seeing whether it highlights or not, you didn't know that it didn't. I don't know if we have any good way to avoid that. But anyway, so your summary of moving to lockstep with the server and simulating based on world consistent with each client, well, it's kind of the opposite of lockstep. Like, it's still the same as the way the networking would work for everything else. It's just everything else doesn't bother simulating. Like, everything else will just interpolate between positions. If they extrapolate, you start simulating. You know, if you want to do extrapolation and not go through walls, you have to start doing a little bit of simulation. You know, if the server said the guy was here moving this rate, and then you haven't heard from the server, and you're trying to figure out where to show him, you extrapolate him forward, but you need to not have him go through the wall. So you have to do a little bit of simulation at that point. And so this would be the same idea. You would just go ahead and simulate everything. You might do a funky simulation for the thing I was just describing. You might try to like cheat the simulation in various ways. And yeah, so for the thing I'm just talking about, you would just go ahead and run the full sim and just let the server periodically update it. The server would still be purely the what am I looking for? Authentic. Authoritative. The server would still be purely authoritative. You would just do it like the normal way in like a shooter or something to do the networking updates is you sort of prioritize. You have a limited amount of bandwidth, and so you prioritize by like, you know, what's the thing you haven't. What's the thing closest to you, the things that are closest to you, the things that are moving fast, and the things that are moving unpredictably. If you do dead reckoning, you actually say, oh, I know my client is extrapolating. So if his extrapolated position is going to match where this guy is, I won't even bother sending where the guy is because he's already going to do the right thing. And one thing you can prioritize is how long it's been since the last time you sent this data for that guy. So the longer it's been, the more you prioritize it. And normally I wouldn't ever do the time thing. I would do a position thing. Like the last time well, you kind of have to do it because of UDP. You do. Let's ignore that for a moment. You would kind of prioritize. Well, it's like how inaccurate is the last thing I sent to the guy? If it's been a long time but it's still accurate, there's no reason to resend it. You know, he's a sniper lying in the field for 30 seconds without moving. You don't keep sending it every half second that he's still there. However, because of UDP, that one packet you sent that said he was there, you might not know that you received it. And what I actually want to do for networking, which I don't know if I'll do it in this engine, that's how Bungie posted a thing about how their stuff works. And that was something that they did, is that they just don't have any idea what the client received, and they just keep sending it. This object is going to sleep. It's, you know, somebody dropped a gun and it's fallen in a crack and not moving and nobody cares about it. So it's really low priority, but we will keep sending where it is, even though it hasn't changed over and over. Because we don't know that they know it. And what I was thinking about doing was actually hacking that if the client can acknowledge, even if it's all UDP, it's not reliable, but if the client does acknowledge it, then you can stop sending it. You have to keep track of that for every client, which is kind of a pain, but might be worth doing. For the factory, drop all that complexity. For the factory, you just constantly cycle based on time, basically. You just constantly, I'm dedicating this much bandwidth to the factory stuff, and I just cycle through everything that's around and update what the current state is. You know, cycling through the available bandwidth, nothing gets priority. The priority is just the time. So that just would be a really simple scheme, so you don't have to worry about the details. The factory might get totally out of sync. Maybe that like never stabilizes. I don't know. Like you'd have to investigate whether that works. But the idea would be to be really simple, because it would be better than not networking it at all. But I might just not network it at all. SEO get performance frequency. Okay. Get performance frequency. Okay. SEO get performance frequency. Okay. Part of the problem here is that the SDL docs are not very good because SDL2 and SDL1 are different, but they are often very similar, and then they don't bother documenting everything. Yes, looks like that's exactly the Win API, basically, right? Okay, now the only question is, do they actually have a uint64 type for? Because is this an LCL type? I don't remember. Okay, so yeah, so we want to know why it's slow. So what we're going to do is profile. So is profile. What we're going to do. So okay, so yeah, so we want to know why it's slow. So what we're going to do is profile. So we really want atomics. Ugh, it's going to be so annoying without atomics. Mesh builder. Capitalized. Okay, if we don't get a task, I pass it in, actually. I pass in 0, 1, or 2. That's this, but let's just use that thing to simplify our lives. So then we say add time, thread ID, end minus start. Profile, managing, start equals get performance counter. And my start prof waiting. Then we have to do this at the end. Off. Oh, we don't know whether it's the mesh or the thing. Okay. So, that's where I have a max workers, max threads. Darn it. Too many maxes. I don't know when it was named. Here we go. Max mesh workers. Okay. Control V, Control Y to get back where I was. Max mesh workers. So thread data thread timing data thread times void add time void add time thread ID u int 64 time load waiting managing processing. And then we say double time spent in all three categories. We say red timing data times executed thread timing data of thread ID dot time spent. And why did that not autocomplete? Did I mistype something? Yes, I did. It's thread times thread thread prof time spent plus equals time over or double get performance frequency thread prof thread ID dot times executed plus equals. So this is how I'm avoiding needing atomics, is I just give each one its own set of data. Plus equals is the sub mode plus equals 1. Okay. All right. So now we are collecting times for all of it. So then when we stop, we wait for all the workers to finish, and then we can print their times. And let's go ahead and say wait 64 sim start wait 64 sim. No, we don't need that to be. Wait, was it like that? Yeah. I hope this compiles. Sim end. So then here, do sim start. Won't be exactly synchronized, but close enough. Equals SDL get performance counter. And then when we shut them all down, and then we can output debug string. Equals end by sim start divided by double still get performance frequency. Then, and let's go ahead and say int 64 sim start int. Then output to string. No, we don't need the time. We're going to do this. For I equals 0, I less than mesh workers. How do you print doubles? It's LF 1.3. We're trying to print a number 100, 0 to 100. So you need, if it's 100, it would be 6, but it will never be 100, right? So you better not take that chance. And we only need 2 decimal places. Wait, 5.2. Let's do process. 5.2 LF. Weight. 5.2 LF. Let's do weight last. Manage. Percent. 5.2 LF. Weight. And that is I. And then what was the name of that? Thread info. Thread prof. Prof. Spent. 0 over time. Where's my cursor? All right, let's see what that does. Int. Okay. Okay. Okay, still generating. Going for a little bit. That's probably enough. Let's see if that prints anything useful. Let's spin that. Here we go. Spent all of its time waiting. Okay. Well, now we know it's spending all its time waiting. And it's spending more than 2/3 of its time waiting, so it could be, part of it could be that we're not, excuse me, is there a, where's the mute? I'm finally eating the snack that I went to get before I started the stream. I'm finally eating the snack that I went to get before I started the stream. Also, my feet hurt from standing for too long. So those weight percentages are large enough that could be only one thread running at a time. It's just cycling through each thread, which would happen with the weight or wake stuff. But it's even worse than that. That would be if the weight was 66. So manage is longer than I would like. It's taking a significant percentage of its time managing. It could be due to bugs. It might be calling the manage part of the code a lot. Okay, so if I take out the weight or weight, it'll just spend all its time in the process because it's just busy waiting in the processing. I mean, not processing, in the managing. Oh. We tried to add a ref count for something that wasn't valid. What does that mean? It was already generated? Oh wait, it wasn't. I'm finally eating the snack that I went to get before I started the stream. Oh wait, it wasn't in the table. We had one in the table, and we added the ref count to it. Is somebody running not inside the lock? How would that happen? somebody updating this and not inside the lock. Lock manager mutex. Do we unlock that at the end, I hope? Yep, okay. Nobody else takes a manager mutex, but nobody else is manipulating the data structures. I think. This would be clear if they lived in separate files, but get next task locks it, but then this thing doesn't lock it. Okay, so that's probably a problem. Somebody somewhere in here is manipulating that stuff without locking it. Yep, right here. Yep, right here. It's somewhere in, but then this thing doesn't lock it. But then this thing doesn't lock it. Okay, so that's probably a problem. Somebody somewhere in here is manipulating that stuff without locking it. Yep, right here. And this also. Okay, anything else in here look like it requires that? Add to queue is already safe. Generate mesh is the core stuff. No, I think that's it. Alright. Got it spelled correctly. Okay, still just as slow as before. Okay, let's check that it was busy waiting like I expected. No, it's still spent all of its time in wait. And now spent no time in process. Nearly no time in process. Wait, these don't add up. Is there some part of this that's outside of a thing? Start, end, add time. That's during exit. Start, end, add time. Start, end, add time, start. Man, I don't see anything outside of that. How do you... I mean, it could spend forever in this or something to make it not add up to 100, but it did it added up to 100 the first time. We're close. What am I missing? I mean, I'm not profiling the time spent in add time, but it seems unlikely. I mean, this could just loop over and over and over and over and spend a fair amount of time at a time, but it's not that much time at a time compared to get next task traversing the list. Because it has to traverse the whole list to hit this path. Okay, so why is this ever failing? Why is there not always work to do? That's certainly a question. All right. Okay, at the very beginning it can fail because the renderer has not given us any work to do yet. So we want to wait for the renderer swap to happen. Okay, then we want to make sure that gets swapped to current. Okay, now if we don't find any work at this point, something odd is happening. And in fact, we never hit this. We are always not work at this point. Then we want to make sure that gets swapped to current. Okay, now if we don't find any work at this point, something odd is happening. And in fact, we never hit this. We are always not reaching this. We are never waiting. So some thread must already be not waking up. We didn't wait, so we don't bother waking anyone. Let's just always wake at this stage. There's a little dead time at the beginning where it's not generating anything. So it will make sense that the times don't add up to 100. But not by the amount that we saw there, I don't think. 0% of the time processing. Let's just always wait at this stage. Let's just always. Just always wait at this stage. There's a little dead time at the beginning where it's not generating anything. So it will make sense that the times don't add up to 100. But not by the amount that we saw there, I don't think. 0% of the time processing. 4 or 5% managing. Wait, still huge. How do you spend a huge amount of time and wait? You never wait anymore. Like literally, start, end. How? What? How? Did I cut? Oh, maybe I cut and pasted something, and it's calling with the wrong one. Nope, that's the only one. How does that? I must be doing the math wrong. Let's do it at the same time. What would, how, what, how, what would, how, what, how, what, that doesn't make any sense. Oh, I did that. I'm printing them in the wrong order. That's why. This is printing 0, 1, 2. 4 or 5% managing. Wait, still huge. How do you? Oh, what? How? What, that doesn't make any sense. Oh, I did that. I'm printing them in the wrong order. That's why. This is printing 0, 1, 2. But they're actually in the order. Order. That's why. Oh, I did that. I'm printing them in the wrong order. That's why. This is printing 0, 1, 2. But they're actually in the order. Processing. Manage. Prop wait is first. So it is spending 0% of its time in waiting. So this is. I don't remember what is processing last. That's prof list. Processing is lost. Okay, so it's spending 90% of its time processing, 4% of its time managing. Okay, so actually it was all working correctly. It just seems to be slower than it used to be, but I can't tell why. Right, so we take this back out, and I bet this is all working fine. But actually, this is pretty safe to do. If we have work, we might as well signal that. Although then it'll always... No, it's only if we have work. Okay, yeah. What? Oh. Prof managing. Prof waiting. Okay. Okay. Yeah, my friend F was wrong. I love that. Okay. So it's spending most of its time processing. So if it's actually slower than it used to be, it has to be doing redundant processing, which is that thing we saw where it seemed like the ratio of procgen to mesh building was wrong. So it might imply that there is a lack of sharing going on. It's still sending 6% of its time waiting. It seems high. How can there be no work? It should never, unless that was just at the beginning. Is there a way I can reset their start times? I can't think of a good way. We'll just let it run for a while. So if it is beginning time, it should get smaller. Right, the wait got shorter. So maybe there's a lot of waiting at the beginning. I don't know. So that seems fine. We'll just leave that in. No reason to disable it. Oh, it does make all this way messier to read, actually, thinking about it. Like, this logic was so much simpler before that. I was thinking about having 2 copies of it, but that would be gross too. Like this logic was so much simpler. Well, so that seems fine. So that seems fine. We'll just leave that in. No reason to disable it. Oh, it does make all this way messier to read, actually, thinking about it. Like this logic was so much simpler before that. Is that any clearer? No. Okay, I'm just getting rid of it. I'll be sad if it turns out I need it again later, but I'll leave that one. Yep, okay, now I can actually see what the sleep is doing. So why would the chunks not be getting shared properly? Generate terrain. Generate the chunk. Lock the manager. Put it in the cache. End the proc gen. Unlock the retex. So we should only start the proc gen if it's not in the cache. So boom, boom, boom. Get gen chunk cache for cord. Is that the cache we were putting it in? What chunk in cache? It is a gen chunk, okay. So then we try to get the gen chunk from the cache. But only if it's not on yet. If we get it, we go pointer to it, we set ourselves to true, we add a ref count for it. Sure seems like it ought to share it. If we don't find it, we check if it's already in progress, in which case we do nothing. Else, if we're allowed to start it, we start it, and we turn that as our task. Yeah, those are all good answers. Yeah, those are all good answers. I mean, why do I make STB libraries? That's clearly kind of for fun. Although there's a there's sort of a socialist thing there, the whole open source thing, right? It's you know, why did I make STB connected components? Well, because my friend Nick Vining was doing Clockwork Empires, well, needed something like that. And I thought, even if he doesn't end up using it, I don't know if they actually ended up using it, but I was like, well, that's a thing that seems like it's kind of reusable and that I can probably write in a couple hours. So, sure. So I wrote it. I made it an open source library rather than doing it as like a little bit of contract work for him or whatever. You know, so it's just sort of the standard open source reasons for doing anything, right? Like for doing any of this kind of programming. And there's definitely I am an engine programmer, so that's why I write an engine. That's definitely a factor. That I don't, when I get on projects like this, I tend to not spend enough time on the game. I mean, here we are. I tried to finally work on the game and start making the crafting stuff. But to be able to make the crafting stuff, I needed... Yeah, those are all good answers. I mean, why do I make STB libraries? That's clearly kind of for fun. Although there's a... there's sort of a socialist thing there, the whole open source thing, right? It's... you know, why did I make STB connected components? Well, because my friend Nick Vining was doing Clockwork Empires, well, needed something like that. And I thought, even if he doesn't end up using it, I don't know if they actually ended up using it, but I was like, well, that's a thing that seems like it's kind of reusable and that I can probably write in a couple hours. So, sure. So I wrote it. I made it an open source library rather than doing it as like a little bit of contract work for him or whatever. You know, so it's just sort of the standard open source reasons for doing anything, right? Like for doing any of this kind of programming. And there's definitely I am an engine programmer, So that's why I write an engine. That's definitely a factor. That I don't, when I get on projects like this, I tend to not spend enough time on the game. I mean, here we are. I tried to finally work on the game and start making the crafting stuff. But to be able to make the crafting stuff, I needed to generate ore blocks and have the logistics simulation be able to know about the ore blocks. And I think that's where we got bogged down into this whole mess of fixing the tech. Even though I wanted to be doing game programming. And if I'm rewriting this background job system because the old one had bugs, and the whole reason why this system exists is for performance, and the performance is terrible after the rewrite, I can't move on. I've got to fix that. The whole kind of point of it. And so as you said, yeah, if you tried to write this in an existing engine, it's voxel based, so that stuff wouldn't work at all. I mean, you just have to make a whole new renderer inside their renderer, and you're not getting that much value. You're getting the value of their existing editors and stuff, but I'm not doing that kind of editing. So you want to edit the voxels. You know, if you started placing entities and stuff, maybe you could reuse that stuff. But a lot of these things are fictional entities, the stuff on the belts that aren't real entities, intentionally for memory reasons and performance reasons. So all of those things, yeah. All right, so I still don't know why the performance is low, and I don't have any real theories. Like, I have the vague theory of maybe the gen chunks aren't getting shared as much as they used to be. But even if I could collect data on how much sharing they're getting, I don't know how much sharing they used to be getting. So I'd have to go back and add this. I'd have to dig out the source control version before I did this change, then add some profiling data to that, and then compare it, and that doesn't sound very appealing to me. So I'm just going to continue staring at the code, trying to think of why it might go wrong. It is spending all of its time in processing, so is there anything else that could have been in processing that would account for that? So it's none of this. The time that's processing I want to get rid of that. So we're still measuring the processing time, and that's the only time we're measuring right now. That shouldn't take very much time. Still using... This could block if we were competing with the renderer there, but shouldn't be very long. This could be blocked by other threads in the manager mutex, but we weren't spending very much time in the managing, so it seems unlikely. If I still had the profiler stuff in, I could try to, well, I do still have this one, so I could try to just profile the time in this. But I bet it's not that, so I'm not even gonna bother. Measure before you optimize. Just don't do what I'm doing. The thing is, this isn't optimizing because it used to be fast. This is fixing a bug, like, presumably. Release gen check, but this is all inside the mutex, right? Yeah, manager mutex. Okay, get junk hard. It's gotta work, because if the cache didn't work, it would never make forward progress. Did I shrink the cache or anything like that at some point? While I was trying to figure out what was wrong. Is it possible I did some change while I was trying to figure out what was wrong? Or not while I was doing something wrong, while I was debugging something. Fix threading bug. Like, how far back do I have to go? Okay, so git status. Let's check the diff actually. So I just done the profiling. Okay, and then how do you check out an old version? I just took the version number right, so this version. Wait, are these top or bottom? Not top. Okay. Git checkout C2331. And then how does it tell me how to get out of the detached state? You discard any commits you make in the state without impact performing another checkout. How do you check out to the newest? I guess you can just explicitly do it. Finding out the newest. Or using the tilde notation or caret notation that doesn't work in DOS properly sometimes. Which is why I just always use the commit. Okay, so. Okay, so. Rebuild. Oh, this might still be in the minimized. Oh, come on. Why is this shader? Because I'd forgotten to check those in at the time of this build. Ugh. Yep, add missing is this one. Hopefully not much else changed. Alright. I should have checked those in separately, but I was lazy. That doesn't seem particularly faster, does it? Lazy. Alright. An old, so this version. That doesn't seem particularly faster, does it? Maybe I just misremembered how fast it is.